Hello, everyone. Welcome. Thank you for joining us here today. All your time is valuable, and I'm really honored that you've showed up for this talk, and there's standing room only. It's pretty cool. My name is Kevin McGuire. I'm at New Relic. I'm director of a team called Infrastructure, and so we do server monitoring, which includes Docker monitoring now, AWS monitoring, and plugins. And so I'm here to talk to you about some stuff we've been working on and some data that we got from our Docker monitoring product that we think is quite interesting and indicative of where we think the industry is going. And well, why is he talking about Docker? This is an AWS conference, so you show up the wrong place. Well, you're going to see that the dynamics are actually quite similar. And so we have that data for Docker, and we're going to talk about how it applies to AWS and the cloud in general. And what I'm really interested in, there's some interesting trends, I think, going on. And to give you a little preview, oh, here's my clicker. There's some interesting trends going on that we're seeing in computing. And we got this from the Docker data. And there's some real implications for the cloud that I want to walk through with you. And then finally, since, well, I'm in the monitoring job, we're interested in what it means for monitoring, because as we're seeing these shifts in computing and how it's being used and life cycles, we believe that there is a sort of evolution that we need to be able to make from a monitoring point of view so that you have the right visibility into what's going on in AWS. So start off for a moment. What are the things we all love about AWS? Well, we love that there's no large infrastructure build out. We love that you can quickly provision what you need, and you can scale it to meet demand. But each of these brings with them these questions about, well, how do you figure out if you're under-provisioned? Or how do you know if you're over-provisioned? How do we even define over-provisioned? And if you want to understand scale out to meet demand, how exactly are we responding to that demand? And in order to be able to do that, you need to be able to differentiate, for example, under-provision from other resourcing problems. You need to be able to define what over-provision means compared to what? Probably cost, and ultimately. And then finally, what does it mean to respond well to demand? How do you understand whether you've provided the right level of service to your customers at an efficient manner? So if we sort of look for a moment at what data we have to start with, we've got some really great information from EC2 and from CloudWatch, but CloudWatch can only give you the view on the outside of the container. It can't tell you what's happening in the container in your application. So New Relic, we're in the business of providing you server monitoring, which provides a view of what your server is doing, and application monitoring, so you understand what your application is doing, so you understand what your end user experience looks like. And so we believe that you need this sort of comprehensive view, all these different places of monitoring to be able to provide a full view of performance. So what does it mean for monitoring tools? Well, first of all, these are the obvious ones. You really don't want to have to install a big monitoring tool and keep it up to date because it's all SaaS here, and so you really want a SaaS-based solution like ours, of course. And you'd like the setup to be low friction because you don't want to be in the job of monitoring, you want to be in the job of building out your application. But the next two are sort of interesting, and that's about that it should be able to handle scale. And because what we're seeing is the scale for the number of, how big the applications are you building in terms of number of EC2 instances is growing quite rapidly, especially as the container sizes are becoming smaller, like for example with Lambda. And it should handle this dynamic life cycle that we're seeing. And I'm going to get to that in a minute. When we did the Docker monitoring product, what we saw was that there were these sort of emerging usage patterns, and I'm going to take you through those patterns that we saw. And why we were interested in that was because we wanted to understand how to build the best monitoring solution that we could for our customers. So at first, when we were using Docker internally at New Relic, we were using it as sort of lightweight VM. We had built New Relic is based on a set of services, and so each service is running in its own Docker container. And so we were using them like this sort of long-running VM where they get started up, they live for a very, very long time. And meanwhile, we started our Docker monitoring closed beta, and we had a whole 49 customers, and we're all anxious to see what they were doing. So we had this monitoring panel up on the wall in our office to see how our customers were using it. And there was this huge upswing in number of containers being reported in a 24-hour period. And we thought, wow, people are really using this a lot. And then all of a sudden there was a drop, and I walked in one day and I saw this on the monitor, and my engineering director said to me, I'm already looking at it, because I thought, oh, we had a bug in our system or something, there was some crash. And it turned out it was one customer who had spun up 20,000 Docker containers and then spun them down in a very short order. So I was like, well, that's interesting. So now it's like, well, what's really going on here? Maybe we're using Docker in a way that it's not intended, because Docker is a new technology, and it's always hard to tell with new technologies what the sort of appropriate way of using it is. And there's a lot of speculation about how you should use Docker. And so we thought, well, maybe Docker is being used more like you would EC2, where you're doing rolling deploys, where you're doing maybe some scale out. Meanwhile, we built out a product called Synthetics, and Synthetics does external availability testing of your site. So you can, for example, give it a Selenium script, and it'll do API endpoint testing for you and give you response time, availability, et cetera. Now, because we're running those Selenium scripts on your behalf in our data center, we want to run them in a secure fashion, so we run each one in its own Docker container. And at the time that we looked at it, we were running through about 60,000 Docker containers a day, and it's probably about 100,000, I bet now at least, in a day, because each one runs, each Selenium script that gets run once, and it runs for maybe under a minute. So this is very different usage, and it's closer to what you would expect from something like Lambda, where it's just one function that's being run for the need of that particular thing, and then it goes away again. So this is kind of confusing. It's like, well, how is Docker being used in the wild? Because certainly internally in New Relic, we're seeing our own usages, and we're seeing some evidence from our customers of different usages. So I thought, well, we can answer these questions, because first of all, we're in the monitoring business, so we're getting all this data. And second, we're data nerds, right? So we can analyze the data that we're getting in and try to understand what's happening in the industry. So this is the result of that analysis, of the data that we collected. And it was over about 1,000 customers, about 8 million containers, so statistically significant. Excuse me. Now, this is a Docker container by number of hours, and that reaches out to the right is about 333 days. And the left axis, the vertical axis, is logarithmic, and that top point is 3.7 million containers. So that's number of containers for a given time period of how long they lived. There's a few patterns that you'll see if you look at this data. The first is this sort of long tail. Well, it's actually not really much of a tail. It's all about the same amplitude. And this kind of looks like what you would expect of use of Docker for kind of VM. And the sample size, it's maybe now 25 to 50, maybe 100 counts per data point along there. Now, just to explain something, you can see that the data gets sparser as you get to the right. And that's because we can get from Docker, we can find out when the containers were started up. We haven't been monitoring it for 333 days, obviously. We just released this in the spring. But we can get from Docker the startup time for the containers, but obviously we can't find out about containers that were shut down before our customers started monitoring them. So that explains why it's sparse, but you can see it's all about the same pattern. This is a little more interesting for us here, and that's that if you look on towards the left-hand side, you can see it's more like EC2-ish. So in particular, there's a spike there that looks like it's about on the month boundary, and our supposition that it might be customers doing rolling deploys on a monthly basis. And so we can see that there is a much higher amplitude, denser usage of Docker in this case as a kind of equivalent to EC2. Maybe it's your on-prem cloud kind of equivalent. And so that sort of validates that Docker containers are being used in this sort of lightweight manner, like EC2 containers, which is indicative of a need that the industry has for these patterns of development, of doing rolling deploys, of having availability, et cetera. But the left-hand side has some really interesting data, because you can't quite see it in this chart, and I'll zoom in. But we have data points up to 3.7 million containers at the very start of that graph. And that shows those are very short-lived Docker containers. And that looks like Lambda. In fact, 46% of the containers that we had monitored lived for under 1 hour. So nearly half of the containers, this was quite surprising. Moreover, 11% of the containers live for under a minute. And this was very surprising to us. We were expecting that there would be some short uses, like we were doing for synthetics, for example, but this is a much bigger data point than we're expecting. And in fact, if you look at the first 5 minutes, it's 27% of the samples. So more than a quarter of the samples that we had of Docker monitoring were very short-lived. And so this indicates to us that there's this shift going on in, Docker's kind of an interesting thing to look at because it's sort of so flexible in the sense of it's a new technology. And so how people are adopting and using that technology is indicative, in some sense, of where the industry is at. And the fact that we see all these different usages of it, and in particular, this very short cycle usage of it, suggests to us that, first of all, Docker is used in all these different ways. But the place that we see the most samples is in these very short-lived containers. And this has implications from a monitoring point of view. Because if you're running through, like us, 60,000, 100,000 containers a day, looking at it at an individual container level, which you would if you were looking at them like VMs, isn't very interesting anymore. You need some other way of looking at it. And in addition, of course, I know the Lambda guys loved this data because it completely validated Lambda as a project. And I think it really is where computing is moving. So if we think about now, where is computing moving, and this notion of maybe computation as a service, where you're just doing the computation for as long as required. So you have some work that needs to be done. You put in a container. Container lives for as long as that work has to be done, and then the container goes away, full stop. So again, this very short-lived pattern just to get the work done as needed. So why does this matter? Well, first of all, as we said, there's these orders of magnitude shift in scale and life cycle that we're seeing. So a lot more containers, and just a lot more because we're building out a lot more in AWS, but a lot more because we're using them in shorter ways, supposition based on the Docker data. And the life cycles are getting very, very short. So there's these sort of orders of magnitude shifts. And I think what's interesting about what we're looking at that Docker data and comparing it to AWS is that Docker, often they talk about the fact that it has better resource efficiency, and it's the same in dev and test and production. The thing that people don't talk about as much is that the startup time on the containers is very, very short. And so that's why I think we're seeing it being used in all these different ways, and why I think it's indicative of where the industry is going, in particular around why I think Lambda is very interesting as a kind of touch point for how we're thinking about doing computation. And so now, since we're using in this way, we have to be able to handle that scale. We have to be able to handle that life cycle. We need monitoring tools that will give us the right visibility into that. And I'll show you in a moment what I mean by that. And finally, we need to measure not at the per container level anymore, but we need to elevate our view of what it is that we're running at the level of what we would call computational intent. So we had talked before about the things you would want from a monitoring tool, and we went through the sort of the obvious ones. But now there's these implications based on what we're seeing as emergence in the industry. And that's that, first of all, it's a big data problem, because you have a lot more containers, and they're running very short, so you get a very large number of them. And so you have this huge volume of data that you need to be able to sort through to understand what's going on. You need ways of pivoting and drilling into the data because it's such a large data set. So the more powerful tools you have for doing filtering, for doing grouping, for digging in, will get you to the answer that you need faster. And finally, to elevate our view, we really need a sort of deeper view. We need an analytical view. We need to be able to get above the level of the individual container that's doing the work and understand what they're doing as a whole. And for that, we need analytics. Excuse me. So this is the screen cap of New Relic server monitoring. And you can see there is a list of servers. And in the server world, these are very long-lived. And I don't know if you know the whole puppies analogy, but I'm not going to use it here because I hate it. Puppies versus cattle. But anyway, these are long-lived, and they're named. And you care about them at an individual level, and you're watching what that CPU use looks like and how much memory it's using, and if you're running out of disk, and because it's going to take a while for you to put a new disk in, and if you're on-prem. And if you're using AWS EC2 as very long-lived containers, again, this is probably the view that you want, because they're going to stick around for a long time, so you care about each of those individual containers. But if they're short-lived, if you've got 60,000 of them, having a list isn't that interesting. It's not useful at all, actually. And so you need some other kind of way of getting above the level of those individual containers. And this is a screen cap from our Docker monitoring product and our use of it in our own data center. So this is New Relic monitoring New Relic. And this is a roll-up view by what we've done is we've taken the CPU usage, and you can do memory as well, on a per container basis, and then we aggregated it, we rolled it up by image. And because the Docker image is the best proxy that we have for what the work was that you were trying to get done, the sort of computational intent that I'm talking about. And so what's cool here is first of all, you can see above the level of the individual container, you can see it at the image level, what's going on, how much CPU you're using, and that's really your application in there. So that you want to kind of view your resource utilization sort of correlated to your application in terms of image. And one of the reasons why I love this particular screen cap is because we happened to capture this phenomena where we were, inside New Relic, we put the SHA of the version in the image name so that we can differentiate them. And you can see that green moving to purple. And that is a version of Insights where we did a rolling deploy of Insights. And we went from an old version to a new version of Insights. And you can see that this deploy marker just kind of naturally emerge. It's this emergent behavior of doing this macroscopic view. We didn't put in a deploy marker. You just saw the deploy marker because you saw the shift of one container being deprovisioned and another container being provisioned, all of which were doing the same work, but a different version of that work. And in fact, if you look closely, you'll see that that line isn't vertical because, of course, we're swapping them out on a per container basis. We've got some new containers of the new version. We're changing the load so that we're sending traffic to the new ones, and then we're turning off traffic to the old ones, then we'll deprovision them. And so you can see the CPU usage of one container type, one version of the application of the image, and then the other, as a sort of vertical, as a slanted line as they're being swapped out. So if we want to think about what computation as a service is, how we would monitor it, well, again, having a list isn't that interesting anymore because there's going to be too many things to put in a list, and you're not going to be able to find the ones that you want. And deprovision containers, and containers here I'm talking about EC2 as well, of course. Deprovision containers are still interesting from understanding performance because they were around to do some work, and you cared about that work when they were around. So if you want to understand what performance looks like, if you want to understand what that behavior looks like, you need a historical view that includes all the containers that existed previously but don't exist still today. And so, in order to be able to get above that level, we really need as much context as we can to be able to analyze what's going on. And just having the sort of idea of the container doesn't really tell you that much about it and some metrics on it. The more that we know about the container, the more analytical possibilities that we have. So we talked earlier about how New Relic, we have application monitoring, we have server monitoring, and now what we're doing is for EC2, and there's a beta that we just announced yesterday, where we're bringing in various information from AWS, what I call sort of envelope information, metadata, like the instance size of the EC2s, what their running state is, what their availability zone they're in. And with that information, what custom tags you've put on them. And we're bringing that information into New Relic to enhance the view that we already have from an application monitoring point of view and from a server monitoring point of view to provide you a more comprehensive view. So yesterday, we launched our beta. And you can sign up for it, and we'll talk about that a little at the end. But the main features of that beta is what we're really aiming for is to help you to manage that scale and help you to manage that dynamic nature of using these sort of short life cycle, highly dynamic uses of AWS. And finally, because, well, it's the cloud, we want it to be a low-friction install experience for you. So the low-friction install, we'll start with that. That's SaaS to SaaS monitoring. So you still have to put the application agent in. It's language specific in your application. And you still need server monitoring in if you want to monitor at the server level. But to get this additional AWS EC2 information, we're pulling it in SaaS to SaaS. So we just set up an IAM role where you give us permission to pull out the EC2 information and create an ARN, paste it in, and you're off to the races. From a dynamic management point of view, we've got now, in addition to the list of servers that you're seeing, it's actually now a folded list of the servers and the EC2 instances. So what I mean by that is where there is for every EC2 instance, there's an entry now in the list. And in some cases, there might not be a server monitoring agent attached to it. So what we're able to do now, because we're bringing in all that EC2 information and we're sort of layering it on top of the server monitoring information that we already have, we get things like we can maintain an accurate list of EC2 instances. And those of you who use server monitoring right now are going to be very happy about this. I'm sure you're really annoyed by this problem, which we call the gray server problem, which is when, from a server monitoring point of view, when the server stops reporting because you deprovisioned the container, we couldn't tell in the past that it was deprovisioned because all we saw was a view from inside the container. And so the server monitoring agent stopped reporting, and we didn't know why. And so it just showed up as, we're not getting metrics for it, so it just showed up with a gray traffic light on the left-hand side. And then, well, they'd stick around forever because we didn't know that they were deprovisioned, and so you had this list that we had to try and clean up for you. And now we'll keep the list up to date for you automatically because we understand their running state. So we understand if they've been stopped versus, so we can get them out of the list, versus there was a failure, in which case we'll keep them on the list so you can drill in and see what happened. So we can enhance the view in the server monitoring view with that instance state that's specific to EC2, and also the status information that you get from the system status information. Again, this is information that we wouldn't be able to tell from within the container. This is information that only you can get from outside the container from AWS, and so we're combining those two views in container server monitoring view and outside server monitoring view from a container level. And as I alluded to earlier, we can actually detect when you have EC2s that aren't being monitored with server monitoring. And since server monitoring is free, you're kind of very well motivated to go and monitor all your EC2s with it because otherwise you have monitoring blind spots. Now, I also talked about the tags and bringing them in. And so there's the metadata, like availability zone, like region, like instance size. We're going to be adding AMI. There's, as you know, I think there's like 100 different properties that we could bring in, and so we're sort of picking through them to see which are the best ones to bring in as what we have as server monitoring labels. If you're not familiar with server monitoring, the labels facility allows you to, much like you have with AWS tags, you get to associate this additional label information with each instance. And in the case of server monitoring, you can do things like you can filter. So you could filter by all the ones that are in a particular availability zone, for example. And you can do what we call roll-ups, which is grouping. I'll show you that in a moment. And this is for both the metadata that we get out of AWS, as well as the custom tags that you've built in AWS we bring into server monitoring. So this is all part of the beta. So just to sort of familiarize yourself with an example, so you can read the screenshots, you'll have the EC2 instance name, and then the little blue boxes are all the labels that were produced from both the bringing in that metadata and the tags. Now, this is, so it's like, okay, since we like to monitor New Relic with New Relic, we're interested, well, what is we use AWS in New Relic. We're a big AWS customer, and we're quite interested in, well, what does our AWS usage look like now? And so this is New Relic, the use of AWS, and by instance type. And this is, so first of all, just so you can read the screenshots, each entry you see is the instance type. There's the number of servers that are of that instance type. And then we have traffic lights which get rolled up. So you could see, for example, if you're having problems with a particular instance type, maybe you were overusing too small of an instance size, and you would see it here because you would see that you were getting warnings or errors from those servers, and you would see that at this rolled up view. The screenshot in the middle on the right don't have those traffic lights just for sake of real estate in the presentation here, but they all have them as well. So this was kind of interesting when we walked through this with our site engineering folks because, wow, we're using a lot of different instance sizes and probably didn't mean to. And so, in fact, you'll see that there's, we've got some pretty big usages. Like, let's see, we've got 736 M3 X larges, very popular in New Relic, it would appear, but only 2 C1 mediums and a few smalls, and probably don't need to be using those sizes. So first of all, this is a good indicator to our site engineering that maybe we should be streamlining our use of different instance sizes, and maybe we're not using them appropriately. Maybe we're, for example, over-provisioning in some cases by using an instance size that's too large. This is New Relic by availability zone. So you can see our AWS usage across availability zones. Again, this is just, all we did was, for all those labels that we brought in, very quick, and I'm not brave enough to demo this live in a presentation, but if you come by the booth, we can show you a demo, or I can show you on the laptop afterwards. But it's really quick too. All you do is you say, okay, you've got a list, as I showed you earlier, of all the different labels. You pick one, and you get these groupings really quickly. And so this is by availability zone. And again, this could be interesting if you're trying to ensure that you had an even deployment of instances across your different availability zones. Or, in this case, again, since the traffic lights are rolled up, if you're having problems in a particular availability zone, you would see it here in this visualization, in this roll-up. Now, we can combine, we can do filtering and roll-ups. So in this case, we've seen the instance types in US East 1, so we're filtering all the EC2s to just the ones that are in US East 1, and then we're grouping them by instance type. So you can see, and then for each of those groupings that we were showing you earlier, you can expand them, and so you can see, of course, the instances that are in that grouping. So we're talking earlier about these problems of how do you differentiate over provisioned, under provisioned, how do you evaluate scale out. And I'm going to show you next is not part of the beta. So everything I've taken you through is part of the beta. This is not part of the beta. What this is some work that we've been doing with our analytics product as an experiment. So the idea is that what we want to be able to do, again, is get above that level of the individual instances. And our Insights product allows us to do that because we can send events to it, and we can decorate those events with additional information. In this case, all of this metadata that we've been bringing in about the labels and the tags. And so what you're going to see is a collection of application metrics and server monitoring metrics, and with that additional metadata attached to them. And one of the keys in here is that we're attaching the EC2 information that we're getting at the container level to the application. because that's the context, again, for which that application is running. That application is running in some different availability zones. It's running in different EC2 instance sizes. And so we're attaching it at the level of the application because in the end, what you really care about is your application performance, because that's what you're in the business of building. And you want to be able to understand that to be able to best serve your customers. So let's talk about what we might mean by detecting under-provisioned. And in this case, these are graphs out of our Insights prototype that we did. So the Insights product with the prototype data. And just to experiment with different ways we can look at this data. And in this case, this is an example we showed of how you could detect under-provision. So let's say, for example, you're getting some calls from your customers about poor performance, and they seem to be region-specific, seems to be specific to a particular region. So in the first case, we have average response time. Now, that's an application metric, so that's what your response time looks like to your customers. So the average response time, but by availability zone. Again, because we know at a container level, all that metadata, we've pulled it in, we've attached to the Insights event, so now we can look at this application metric in terms of EC2 metadata information, which I think is pretty cool. And so in this case, in this example, you could see, for example, that your US East, US West 2 is performing poorly. So the average response time is much higher than all the other ones. And you go, that doesn't look so good. And well, I wonder what the EC2s are doing in terms of, from a server point of view, in terms of resource usage point of view. And you might see that now compare, again, availability zone, but now CPU by availability zone. So that's a server metric by availability zone to now detect, okay, it looks like our CPU usage is quite high across that availability zone, so across all those instances. And then if we looked at the types of instances that we're using in each of those availability zones, we might notice, we're using, for US West 2, we under-provisioned. So we don't have enough C4 larges and C4X larges compared to the others. And so that would be an indicator to you that you under-provisioned. Now, what does it mean to over-provision? Well, we can take the same example and walk through. And in this case, we might notice that for US East 1, that the response time is actually too good. You don't need that good a response time. And so we're sort of leaving money on the table, if you will, from a cost point of view. And if we look at average CPU usage, again, across that availability zone, we might notice that it's really low and go, wow, that's really quite wasteful. Well, what's going on? Again, if we look at the instances, we'll see that maybe we provisioned the wrong type. So let's say we might have provisioned a C4 4x large instead of a C4 x large, because the person who was doing the provisioning is old like me. He's got glasses on and he looked at it wrong and typed in the wrong thing. So in this case, since as you know 4x larges are 4 times the cost, you'd be wasting a lot of money by over-provisioning, and you would be able to detect it here. Now, finally, let's talk about evaluating elasticity and high availability. And how do we want to think about responding to availability? One way you can think about is in terms of what the throughput looks like for the requests that you're getting in versus the response time that you have to ensure that you're meeting that throughput and your resource usage in order to support that usage. And so in this case, let's say you're looking at your EU availability zone because there's a holiday in Europe, because as you know, there often is. And so you want to see, okay, well, we've got a lot of customers are on holiday and they're using our application quite heavily. And so the top is you see that there's that throughput spike. And in the middle one, you can see that the average response time took a bit of a hit and then settled down again. So great. And that was because you saw the number of EC2 instances in those availability zones were increased. So great. You saw that your availability triggered correctly and provided the right customer experience that you were looking for. Fantastic. Now, you might also notice, however, that once that throughput dropped, your response time got, again, too good. And that's because maybe you forgot to deprovision those instances. So that's the sort of other side of the coin from availability. How can you be sure that you stopped being available when you didn't have to be available anymore, and you'd be able to see it from this kind of visualization? So ultimately, we want to get above the level of the individual instances, because what we want to be able to do as a monitoring company, we want to be able to help you to understand what's going on in your infrastructure, in your application. We want to help you to get the best customer experience that you can for your money. And how you do that ultimately is you want to be able to dial at a final level as you can manage the most efficient use of a set of resources to achieve exactly the customer experience that you want. No more and no less, because if it's not good enough, you're going to have poor customer experience, and if it's too much, then it's going to be too costly. So you really want to try and balance all three of those. In order to do that, you need these macroscopic, these emergent sort of views of performance across your applications, your servers, your EC2 instances, all informed by this additional information that we're now bringing in from AWS. So if you go to newrelic.com/AWS, you can sign up for the beta. And and we're bringing in customers gradually because we want to be able to work with you to get feedback. We're not a startup anymore, but we still act like a startup, a lean startup. We want to get something out, to get it out to you, the customer, to evaluate it, to give us feedback so we can make it better. So this is the first of many versions that are coming out. So that's the beta that we just launched. And if you go to that site, /AWS, you'll also see there's some demo videos. You can see of it in action. And certainly come by booth 203. We have a really great booth location. It's like basically right in the door as you come in to your left, and we'll be happy to demo it for you. Two other talks that I think are interesting with this shift to what we would call the serverless cloud, which is there's a CMP301, Lambda in the serverless cloud. As you can tell, I'm a big fan of Lambda. I think it's really interesting from the point of view of where, again, the industry is moving to. And really, I think in the end, we're not going to have any servers anymore, or the notion of a server is certainly drastically changing. And then it's 201 microservices architecture. Again, Lambda, DynamoDB, big fans of all those. So finally, please fill out your evaluation, and thank you for your time.